Hello and welcome from beautiful Paola, Kansas on the Friday of testing. So what we have for you here is the Conair turbine put together by yours truly, Sam and Aaron. As you can see, it's not the prettiest turbine, but this year, since it's all online, we chose to go for efficiency over what you might call aesthetics. So first we get into the CAD process. As you can see on the presentation we've sent you, the first slide is CAD. The CAD process was very long, and the main problem with the CAD process was that me and Sam had never used Onshape, which we used before, but we'd heard it's a good program and we decided to give it a try. As you can see with that, it looks kind of janky because of problems I had, but for a good basic understanding of the turbine and what we wanted to do, it worked out fine. Sam, we'll start on the base.
For the base, we used old deck railing that we welded together to make a crisscross pattern and make it stronger. And on top of that, we used old floorboards just so we have a base to screw these poles into. We used PVC for the poles and then just 1-inch plywood on the top. We actually used other pieces of the deck rails for these L brackets here, and we actually spent no money building this. So the gearbox is completely 3D printed other than the axles and the bearings. The axles and bearings are 1/2-inch hex. We use that so they don't slip on the gears when it's turning because of how much torque there is. It's almost all 3D printed.
Moving on to the blades. The blades are made out of a special corrugated. So the past couple of years we've been using corrugated plastic as our blades, and this year we decided to take another route. We went more traditional, tried to go with airfoils. The thing with airfoils is it's really hard to make out of a flat material, as many of you might know. So what we did for that was we took a corrugated PVC pipe. It's got corrugated holes. It's very light as the corrugated plastic we've been using is, but it is in the shape of the PVC pipe, which gives us the chance when we cut it out to have a nice bend to catch more air with it. They're all about 1.5 feet in length, and then at their widest probably about 3 inches in width. So we're hoping when we test that it will give us a very good outcome with the ability to catch air.
The gears are all a 100 to a 12 ratio. We'll do that 3 times. We didn't try to go for a certain ratio this year. We just tried to make it as fast as possible with what we had.
And as my partner Sam said previously, everything on this base and on this turbine you see has cost us zero money. We've either found this through recycled stuff with the floorboards that they used on their house and didn't completely use up. We used stuff like the deck rail, which I found and we cut up and used. The gearbox is made out of PLA that he got for free. Even the axles, which are a fairly expensive axle, we got for free from a robotic shop in Paola that donated it to us. Same with the bearings on there, the 1/2-inch bearings, hex bearings. Those are fairly expensive bearings in themselves, and we've been very thankful that the robotics team has let us use these. It was a big help not to have to worry about money this year, especially with the ongoing COVID-19 issue. So we didn't have to go out and try to get sponsors for money.
Anything else?